Hi everyone, it's CKRC. Let's build an OMPHOBBY M5. In this video, I'll be going through the assembly process following the pages in the manual. Page 1 covers the process of assembling the main plate and upper side panels. We can get started with the main plate assembly. The hardware you'll need to assemble the main plate are going to be the M3x6 screws, as well as the countersunk M2.5x4s. You'll also need your canopy spacer sleeves, the long screws, which are M3x40, the rubber caps that go over the end of the M3x40 screws, as well as the frame stiffeners. Finally, you'll actually need your bearing as well. In my case, I like to use Loctite 638 as a retaining compound for my bearing. I find that it kind of can help to keep things in its bore. The machining tolerances of what I've seen with the OMP helicopters is pretty darn good, so like honestly you probably don't need it, but I like to go that extra step, so I'm going to be using 638 for my screws and such. Unless they're critical components, I'd like to use Loctite 243, which is going to be thread locker blue. I'm going to go ahead and start off with putting the bearing into the main plate. So I'm going to flip my main plate over here. We can see that the bore of where the bearing will actually go. I'm going to put a little bit of the 638 on this bearing and then go ahead and place it into the bore. Now that that bearing is sunk into the bore, I have a little bit of the excess green Loctite, so I'm going to go ahead and wipe that off. And that is our bearing. The next thing we can do is work on the long M3x40s with the canopy spacer sleeves. So we're going to go ahead and stick the sleeve over the screw, and we actually have these threaded holes right here that are in the main plate here. So I'm going to go ahead and grab, this should be a 2.5 millimeter hex, and apply Loctite, and then I'm going to go ahead and do the same thing for the other side. Now that the M3x40 screws are in the frame, I'm going to go ahead and put the rubber caps over the end of them, and those are our canopy spacers. From here, we can actually move on to the wire guide. So there is a carbon plate that is included in the bag, and this is actually here to help with running your wires from the front to the rear of the helicopter. We want to go ahead and make sure that we're putting this on the the correct side of the plate. So it's going to be the same side of the plate or the bottom of the plate where you sank your bearing in. We're going to go ahead and see that the plate actually has the countersunk bores here. Place that up. Take our countersunk screws. These are going to use a 2 millimeter hex driver. Apply a little bit of Loctite to these screws. And you can see that the way that this carbon plate works is it's actually here to basically give you a nice way to run your wires out of the way of the main gear and things like that. And the holes here are perfect for zip ties, so you can actually secure your wires. The last thing I'm going to do is go ahead and put our frame stiffeners into place. So they are different, so you want to make sure that you put the correct frame stiffener on the correct side of your main plate. So when we're looking at the top of the main plate, which is where we basically didn't sink our bearing in, and also your serial number will be upright, we actually are going to have our main plate, or our frame stiffeners facing backwards like this. And so now I can take my M3x6 screws using my 2.5 millimeter hex driver, put a little bit of Loctite on them. We can go ahead and thread them in. Okay, and that's our right side frame stiffener. I'll do the same thing with the left one. And those are our two frame stiffeners. We've now actually finished the main plate assembly, so we can go ahead and move on to the upper side panels. To attach the upper side frames to the main plate, you'll need your 6 M3x8 screws, as well as the 2 M2.5x6 screws. The M2.5x6s go into the frame stiffener, and the M3x8s go into the main plate itself. And so you can take your side panel, they're actually going to be the same on either side, and go ahead and place it up here against the side panel. Goes into the middle, as you can kind of see. And when you place it up here, you can see that there's a smaller hole here for the frame stiffener, and then the M3x8s are actually going to go into the holes here. Now, one thing to keep in mind is that you are not going to put a screw into the rearmost hole of the frame. There's actually going to be a different screw because it's a kind of a sandwiched assembly that we will put together later on. So the first three holes here against the main plate are going to have our M3x8s, and then the M2.5x6 is going to go into the frame stiffener. So using a 2.5 millimeter hex driver, I can go ahead and grab my first M3x8. I'm going to put my Loctite on it. I'm going to go ahead and place it through the frame, upper side frame, line it up, and start to loosely thread it in. I'm not actually going to go ahead and crank this down just yet because I want to make sure that we have everything lined up correctly. I take my second one here, go ahead and put it into the front of the two screws for your side plate. Like I said, once again, I'm not going to tighten those just yet. I'm getting them like, close to the point where the frame can kind of still move around a little bit, but we're not like fully tight yet. Now I can take my M2.5x6 with my 2 millimeter hex driver, go ahead and thread into the frame stiffener. I'm still not going to tighten these down just yet because I want to go and put the other upper side frame on. And so now I can kind of place that on its side, and we can repeat the same thing. Once again, you don't want to put a screw into this rearmost hole, so just the first three here, so this one, and this one, as well as the M2.5x6 into your frame stiffener. So now I have everything kind of loosely fit. The best way you could do this is actually to take something like, a surface is truly going to be flat, like glass. My desk should work good enough. I'm going to go ahead and actually just make sure everything is kind of settled into place here with my main plate. And then, that I don't have any weird, wobbles or anything along those lines. And then I can tighten down all of my M3x8s as well as the M2.5x6, and that will complete this assembly. All right, and there we have it. Here's our upper side frame assembly assembled. We're going to continue the assembly here with page 2. Page 2 entails the servo rack as well as the sacrificial canopy mounts. If we look at the servo rack parts, we can see with M5, the 15 millimeter servo rack parts are included, and that's because M5 is designed for 15 millimeter cyclic servos. These are sometimes called mini servos depending on the market, but it's easier to specify 15 millimeters because that's a lot more precise. It is possible to run 20 millimeter or full-size servos with M5, but this requires a conversion kit that is available separately, or you can just get an M6 if you really want to run those servos and not have to get a conversion kit. For the servo rack assembly, we have our upper and lower servo, really this is the upper and this is our lower servo mount. We have our main shaft cover, the bearing that goes into the upper servo mount. We have 6 M3x6 screws that hold the servo mounts to the main shaft cover, and then the 3 M4x10 screws that are used to hold the entire servo rack assembly down to the main plate. To start off with, you can grab your upper and lower servo mounts. If you look at them, you actually can see that there is a kind of an embossment or an area for the main shaft cover to slide into, and it does slot in quite easily here. So if I just place this here, you can see that with this being my upper servo mount, the one without all the complications and the provisions for the M4 screws, it'll just kind of slot in. The lower mount has the same sort of embossment in it. And if I place this up here against my servo rack assembly, we can see that things kind of just slot in, and your 6 M3x6 screws will go into the corresponding holes here. And I'm going to go ahead, put some Loctite on them, and get those put into place. Using a 2.5mm hex driver, I can go ahead and put some Loctite on these screws and drive them into place. Now that we've gone ahead and assembled our servo rack, we can take our bearing, the 6801ZZ, so our double or shielded bearing, and put that into the upper servo mount. So if we actually look at our servo rack assembly, we can see that the M4 screws will actually go into these kind of the area here that's extended out of the lower mount. And then our bearing actually will fit into this slot here. Now, I like to use 638, as I've mentioned many times in my videos. So I'm going to go ahead and apply 638 to this bearing and get it set into place. Clean up my excess Loctite 638. And there is a completed servo rack assembly. Using the M4x10 screws, I can actually slot this into place. Now, when I go ahead and line this up here, we can actually see that it doesn't really matter how you put this into place. Regardless of the placement of it, it should go into, it's going to be the same. So just go ahead and place it in however you want, and grab your M4x10 screws. These do use a 3mm driver, hex driver, so you can grab one of those, grab your Loctite, and get these driven in. Now, whenever I'm assembling something like this, even though the machining tolerances are great, I'm actually going to not just go down and crank down on one of them. I want to kind of evenly tighten them as I go down. So they're snug, but now I can actually put the torque that I want into them. And ideally this keeps things all in alignment. Although I would imagine that honestly, if I were to do it without that procedure, it'd probably still be in alignment. For now, we can go ahead and take our upper frame assembly. We'll put this up here off to the side, or up here, and I'll grab the components we need for the canopy mount. Now, the canopy mount mechanism is going to be similar to what is found on M7. So this is a sacrificial canopy mount. The spacers here are going to go against the wider side of the carbon plate, and the carbon plate is actually here to both design to brake as well as pivot out of the way in the event of a crash. So we can grab the M3x8 screws, put those off here because that's how we're going to mount the sacrificial canopy mounts to the frame, and then grab our smaller button head M3x6s and the ball head screws. Now we need two 2mm hex drivers for this, so I'm going to go ahead and put these off to the side, put my tweezers off to the side, and I can kind of show you how I like to assemble these, and that's just because I don't like using pliers on, anodized aluminum like this. So I can go ahead and grab the ball screw, take my Loctite, apply it to the ball screw. We can also, I'm going to go ahead and slot the button head M3x6 through the plate. Grab this, like so, put some Loctite on there. That's a good amount of Loctite. And then now I can start to thread the post on, and then taking the ball screw, that then can get tightened into place. And the reason I am using two 2mm hex drivers here is because I can tighten this kind of like you would a spindle, and that should put an adequate amount of torque into this, and alongside with the Loctite that I'm using, it should actually keep everything tight. I'm going to go ahead and repeat the steps for the other side. Tighten them like a spindle. Move my 2mm out of the way because now we need our 2.5mm driver for the actual mounting of these to the upper side frame. Now, if you remember with the previous page, for page 1, we actually didn't put a screw into the rearmost hole for the upper side frames, and that's actually because the screw for the canopy mounts goes into that hole. So now I'm going to stick that through the narrow end of my sacrificial canopy mount, or the carbon plate for that, put a little bit of Loctite with my M3x8 screw, and thread this into place. Now, as I'm going down here, you can kind of see it will index and slot into a hole on the frame, and that's why you have that button head. So as I tighten that down, I'm trying to keep everything in alignment here. So looking on this side, we have the hole that the button head screw will index into, and the M3x8 will actually go into our main plate. So taking the M3x8, I can stick that through the narrow end of the sacrificial canopy mount, carbon plate, add some Loctite to that screw, flip it over, and repeat the same process. Alrighty. And there we have it. We've now completed page 2. We've gotten our sacrificial canopy mounts installed as well as our servo rack assembly. We can continue on to page 3. Page 3 is a relatively simple page and just covers the ESC mounting plate, taking the mounting cross members, using countersunk screws to attach them to the ESC mounting plate, and then mounting it into the frame. So to start off with, we'll take our countersunk screws, which are the M2.5x5 screws. There should be 6 of them in your bag for page 3. Apply a little bit of Loctite to the screw, stick it through the upper side of the ESC mounting plate, and start to thread this down using a 1.5mm hex driver. And you'll do this for all 3 of the mounting cross members, so using 6 M2.5x5 screws total. When I go and am threading in my countersunk screws, I like to leave the first one loose so that I can move the mounting cross member around. You want to make sure that the flat side of the mounting cross members is what you're threading into. Can't really get it upside down because the threads of the screws won't actually make it all the way to the cross members, but just make sure that you're mounting the plate against the flat side of the cross member. Now that the mounting cross members are mounted to the ESC mounting plate itself, I can go ahead and grab the upper frame assembly, move that into the center of the screen here, and place this into the upper frame assembly. The manual says to use Loctite on these screws. That is a great idea. I'm actually not going to put the Loctite on these screws just yet because I intend to remove this plate when I go to do my ESC installation and run my wiring. So I'm going to leave these without Loctite for now, but I will have to take these screws back out because I like to run my ESC wires and a capacitor pack underneath the ESC plate. You'll also note that there were only 4 M2.5x6 screws included in this bag, and that's because you will not put a screw into the front mounting cross member just yet. You'll be doing that on a different page. With that, we have our ESC mounting plate installed. For page 4, we're going to go ahead and put together our main gear assembly as well as our main pulley assembly. When we take our main pulley, we can take our carbon plate and match it up to it. We can rotate the carbon plate and see that the holes will line up. The carbon plates are the same. They are directional in the sense that with the countersunk bores, you need to make sure that the countersunk bores are facing outwards from the pulley, but when you put them on to the plate, the main pulley, you just want to make sure that the holes line up. Once you have those holes lined up, you can take a 1.5mm hex driver with your countersunk screws, and using Loctite, go ahead and put them into place. Now, I like to leave the screws a little bit loose initially until I get all of them into place, and then at the end I will tighten them down in a star pattern. Now, with all 6 of the countersunk screws into place, I'm going to go ahead and tighten them down in a star-like pattern. And there is one of our pulley flanges installed onto the pulley. We can flip it over and do the same thing again. The main pulley is now assembled. We have both of our pulley flanges bolted into place using our M2.5 by 5 countersunk screws. We can go ahead and move on to the main gear assembly. We can take our hub, and if you look in the manual, it shows you that the rotor overrun text needs to face upwards. The 115 tooth gear will actually be upside down here. So with motor overrun, or rotor overrun actually facing upwards, I can place that down on the desk and this will slot into place here. The fit is tight but not impossible to get into place, so it slides in nicely. And then we can take our M4 by 10 screws and flip the gear assembly over, and on the side that the 115 tooth marking is on, we can put Loctite on these screws and drive them into place using a 3mm hex driver. I'm not snugging these down until I have all 3 of them installed, and I'm going to tighten them down evenly with the hopes of reducing the amount of run out that this assembly will have. Now that we have our main gear assembly done, we can find the spacer that was included in the bag. We won't necessarily need to use this right now, but you need to remember that the spacer is going to go between the main gear assembly and the bottom of the main plate. The main pulley will go underneath the main gear assembly on the side that the 115T is marked on, and the actual hole on the main pulley for the bolt that goes through the main shaft will go on the outer side of the assembly like this. So for now, I'm going to go ahead and place these off to the side, but when we go to install our main shaft later on, we'll need to remember that we need this spacer, so don't misplace the spacer. Page 5 details the main shaft and how to install it into the upper frame assembly with the main gear and main pulley. The spacer that we had from page 4 is still very, very important to keep in mind right now. I'm going to show you how I kind of drive things into place. The M5 uses a 15mm cyclic servos, which means that it has a 170mm main shaft, which you can see is marked on the main shaft itself. And the orientation of the main shaft is important. The larger or longer length from the end of the main shaft needs to go towards the bottom of the helicopter. Now, this is actually pretty obvious on this shaft because it's chamfered on the end here, and that's going to make it so that the chamfered side needs to drive down towards the main gear and so forth. If you look at the main pulley, you'll note that one side of it has a rectangle for where the bolt that goes through the main shaft is we have a side with a rectangle and then one side with a circle. The circle is going to mate to the head of your socket head cap screw, and then the rectangle is going to mate to the nylock nut that is used here. So to go ahead and install our main shaft, we're going to take it, drive it down through the servo rack assembly. As it starts to come through the bottom here of the frame, I'm going to take my spacer and go ahead and put that into place. Now, you don't want to just stick this all the way through. Take your main gear, and the kind of geometric side of the main gear is going to face towards the servo rack assembly, so the 115T is going to face downwards, and in this case it's facing upwards because this is the bottom of the helicopter. So make sure that that's correctly oriented. Go ahead and continue to push the shaft into place. Now we can take our main pulley, put it into place here as well, and making sure that the provisions for the bolt that goes through the main pulley and main shaft are going to be on the bottom of the helicopter. Now you will note that the main shaft continues to come through past the main pulley for a decent amount of distance, and that is because there is a third bearing block that we're going to be installing later on. Once that is there, we can take a 2.5 millimeter hex driver with our bolt, our M3x20. We can send that through the pulley on the side that has the circle with our shaft. Send that through. Take our nylock nut and go ahead and thread that into place. Now, the nylock nut will index into that rectangular cutout of your main pulley. If it doesn't lock into place as you're trying to tighten this down, make sure that you have that orientation correct. I'm going to go ahead and tighten that down. And here we go. We have our main gear assembly as well as our main pulley installed. Our spacer is between the main plate and the main gear assembly, and we are ready to continue on. So pages 6 and 7 are combined into the same bag, and that's because it's the entire lower frame assembly. Now, if we look at the hardware on the table, it looks like we have quite a lot. Now, I can break this down as I've kind of organized it out. On the left here, we have our auxiliary plate. So this is going to be our plate as well as the mounting cross members. For this plate, we have 4 countersunk screws that are going to be used to mount the plate to our mounting cross members. We have a battery latch, and this is the same battery latch as you'll find on the M7. The only difference is we have 1 instead of 2, and we use button head M2.5 by 6 screws to hold the battery latch onto the frame for the battery rail. In the middle here, kind of in this section, we have M2.5 by 7 screws, the canopy spacer sleeves, as well as the rubber caps for the canopy spacers. It's important to note that we have M2.5 by 7 screws as well as M2.5 by 8 screws, and there are a lot more of the M2.5 by 8 screws. There are 6 total. So when you go through your hardware bag, you want to make sure that you find the slightly shorter M2.5 by 7 screws, because if you don't and you use the wrong screw for the canopy spacers, you'll end up with screw threads protruding into the area where your battery tray goes, and that's not necessarily ideal. So just make sure that you look for those M2.5 by 7s that are slightly shorter than your M2.5 by 8s. We have these countersunk nuts. Now, these are custom made, but need a little bit of special care taken to them. I'll show you kind of how I like to glue them into the frame, but you will actually have to glue them into your battery rails Now, these are the battery rails. They are different, and if you look at them, they actually have a countersink that matches to the countersunk nuts. I like to use CA to glue the countersunk nuts into the battery rails. The reality is that when you go to glue these nuts into place, and you make the battery rails to your lowers, they're pretty much going to be mated for life. You're generally never going to have to take that apart, but if you want to be really careful about how you apply the glue and so forth, you can actually, I'll kind of show you what I keep in mind there so that you can get everything disassembled if you want to. Finally, we have our little M2.5x4 screws, and these are actually used for mounting on, it's primarily on the right side of the frame, but we're actually going to use those to mount the battery rails to our lower frames. To start off with, if we actually take our lower frames here and I spread them out, we can see that on the right side of the lower, we have a hole here, and that's the provisions for our belt tensioner. So you can see that in the frame, and actually on the battery rail that matches this frame, we have that same hole, and it's also called out in the manual. So when this battery rail is actually put into place, it's going to be on the inside of our lower frame and sandwiched together like this. Now, the cinch nuts that we have here, or the countersunk nuts, are actually going to go into these holes, these bores, and then they're going to stick through our frame, and actually that's how we are going to then use our M2.5x4s and a few other bits of hardware depending on what we're specifically trying to mount. The battery latch actually uses the button head screws instead of the M2.5x4s, but we'll go over that on the left side of the frame. So I'm going to go ahead and put these lowers off to the side for now. I want to focus on how to glue the countersunk nuts into the frame. Now, if you really aren't expecting to have to take this apart again, you can just keep them or not even glue them in at all. But if you want to be able to remove those screws potentially down the line, it's going to be pretty important that you actually use you glue them into place with something like CA or even epoxy. The tool I like to use for applying the glue to the nuts is actually a pair of tweezers. Now, I'm going to go ahead and stick the tweezers in on the bigger side of the nut, and then if we look, we actually have that the face of the nut relatively easy to spin around and apply glue to. Now I can take my super glue. Now this is actually the extra thick stuff. I find it easier to work with, and it doesn't set as easily or set as quickly. And just ever so slightly apply a little bit as I'm kind of rotating this nut around. So our goal here is not to put so much on that it overflows and causes a whole bunch of problems, but also that we put enough there so that it actually will hold. I like to take a toothpick and actually spread this around a little bit, and if I actually put too much glue into place, I can also use the toothpick to kind of pull a little bit of that glue off. Now, once that's there, we can take our battery rail and stick this into place. Now, what I'm going to do here is I'm going to squeeze my tweezers a little bit, and then that should just pull right out. And so we have now just glued our nut into place. Now, using a paper towel, I can clean off a little bit of the excess super glue, especially because I'm using the extra thick super glue. And that's going to be the process for one of my countersunk nuts. We can continue down the line of gluing them into place using a similar procedure. I mean, you can use pliers or whatever you want, but the important thing is just, you don't really want to disturb it while it's trying to set. So I'm going to do the same thing again. Grab my tweezers, put my nut on it, take my super glue, take the battery rail, sink that into place, use our paper towel to kind of wipe that excess on this side of it. And now we have our 4 countersunk nuts on one side of, or one of our battery rails done. I don't insert this into my lower frame just yet because the CA is still wet and will actually glue the frames together, so I don't really want to do that. You can actually, if you have a little bit of overflow on this side, use something like a toothpick, try to like clean up the area there, or you could even use a paper towel. But I actually am going to go ahead and put these off to the side and let them cure, so that there's not really going to be any problem having like wet glue or something along those lines glue my frames together. I'm going to continue down and do the same thing for the other battery rail. Sinking the nut. I've got all 8 of my countersunk nuts glued into place on my frame. I'm going to go ahead and let them kind of set and cure here, but in the meantime, I'm going to focus on the auxiliary plate. So we can take our auxiliary plate, our 4 countersunk screws, and our mounting cross members. We can take our Loctite, come back over here, and do the same thing we did with the ESC plate. And go ahead and mount our mounting cross members onto our auxiliary plate. And our auxiliary plate is done. So moving on to actually mating the battery rails with our lowers, we can take our lower, and when we place the lowers over the battery rails, we can see that the countersunk nuts will actually index into our lowers. And it's a nice fit into place, like so. The same thing can be done on the other side. And with those mated, we can actually go over what we're going to be doing with our various screws. So if we look, the left frame, and this is detailed on page 7, is going to use the button head screws, the M2.5x6 button head screws, and the battery quick release is going to go in on the left side of the frame. So we won't be putting in hardware there. Now, the front of the helicopter is going to have the canopy spacers, which is going to be where that M2.5x7 screw is going to go. So we can actually start there. If we take our M2.5x7 screw, we place our sleeve over it for the canopy spacer, put a little bit of Loctite on that, place this down into place. That's going to be our front canopy spacer. Then we can put our cap over that and do the same thing for the other side. Now, for the right side frame, which is the one detailed on page 6, we can actually use our M2.5x4 socket head cap screws, so the super short ones, and we'll use the spacers, the silver spacers, and put them into the 3 other spots here for our countersunk nuts. All right, so now our right side lower frame is complete because our battery rail is now mated to our frame. Now, if you recall, I was very specific to mention the M2.5x7 screw, and the reason is because if you use the M2.5x8, you'll actually have the threads protruding out of here, which you really don't want, because that could actually snag your Velcro or even your battery if you actually have a battery that's wide enough. Going back to our left lower, we can take our last M2.4 or M2.5x4 screw, put a little bit of Loctite on it and put it into our rearmost hole for the countersunk nut. Okay. Now, our battery quick release can be put into place. So you can place that there. Now, it's really important that with plastic, you're kind of careful with Loctite. Loctite can cause plastic to fail. Using my 1.5 millimeter hex driver, I'm going to go ahead and put just a little tiny bit of Loctite onto this and not have so much that it will contaminate the plastic. So when I stick it through, there should be not any Loctite that gets onto the plastic. We'll do the same thing for the other side. Drive that in and tighten these down. So with that, our battery quick release is now installed and our lowers are actually pretty much done. The last thing to do is to grab our 6 and 2.5 by 8 socketed cap screws, because we're going to now mate our lowers to our upper. Grabbing the upper, I'm going to go ahead and place the aux plate in the front here, so you can actually see that the aux plate will slide into place here. And there are, if you look at our upper here, we have a hole in the front. There's already threads behind it because that's part of our ESC plate. And the auxiliary plate will slot in right behind that. And once you get those somewhat lined up, you can actually go ahead and grab your lower that corresponds to the side that you're working with and send things into place. Now, for the purposes of helping to keep things aligned, because this is a little finicky, especially when trying to do it on camera, I'm going to go ahead and do this without Loctite initially, but I want to come back through and pull them out to put Loctite into them. So that screw has Loctite, or sorry, does not have Loctite. I'm going to go ahead and put Loctite on this one, which is going to go into the front of the aux tray. Then go back over here, pull this back out because I didn't put any Loctite on it. Put Loctite on it. Put it back in. I'm not going to snug that down just yet. And actually, for my front screw that goes through the frames and into the ESC plate, I'm actually also going to leave that one dry because I still have to pull that off for when I do my ESC plate or my ESC install. Now, we can do the same thing on the other side, except now because the plate should be somewhat held into place, I'm going to go ahead and Loctite my screw. Kind of seek it into place. Still not going to snug that down just yet. Loctite on the other screw for the auxiliary plate. Leave this one dry for the ESC plate. Okay. So now that that is done, if we kind of set things upright, we can sort of see that things aren't, rocking back and forth. So I'm going to go ahead and tighten these down. And the ESC plate one is not necessarily as important, but still definitely something we want to keep in mind. Tighten that. Tighten this. And tighten the ESC plate, or the front screw for the ESC plate. And now it's starting to look like a helicopter. We have completed the upper frame assembly, the lower frame assembly, and you can actually see how we have the 3 layers of carbon sandwiched into place here. Main gear is installed, main pulley is installed, main shaft installed, servo rack as well, our ESC plate. We are done with pages 6 and 7. We'll move on to the belt tensioner and tail boom mount assembly. We'll start off with the belt tensioner assembly. And what we'll do is we'll want to take our base plate and kind of make an observation that there is a threaded hole on one side with a standoff, and that's going to be the side that the tensioner is, the loose tensioner is going to go into. So if we look at our mechanism here, we actually have this arm that the pulley will be bolted into, and that will pivot on our tail belt or tail idler assembly, and that'll provide the ability to give the adjustable belt tension, which is quite a convenient feature when it comes down to it, from what I've seen. So to start off with, I actually am going to go ahead and take my pulleys, and I want to set my bearings into them. So I'm going to move my flight controller mount off to the side. We'll kind of move my parts out of the way as well. I'll start off with my idler pulleys. So we can grab the 4 bearings as well as these spacers that go between the bearings. It's really important to make sure that you have those bearings where they're supposed to be. I do like to use Loctite 638 to apply and set my bearings into place. So I'm going to go ahead and apply the Loctite onto the outside of my bearings here. Then using my driver, I can make sure that, or I can try to make sure that the alignment is proper when I go to put this bearing into place, because otherwise what will happen is it will not go in very nicely. There's our first bearing into our idler pulley there. Now the second bearing I'm going to go ahead and put onto my 3mm hex driver, as well as the spacer, because that's going to go between the 2 bearings. Apply my green Loctite here, and then go ahead and make sure everything is lined, and that'll set right into place like that. So now we have our idler pulley assembled. I'm going to go ahead and clean off the excess green Loctite. We can go ahead and move on to the other side. That's 1 pulley, or 1 bearing into the pulley. Go ahead and make sure I put the spacer on. There we have it. Our 2 idler pulleys are now assembled, and we can move on to assembling the actual idler arm for the tensioner. So we can move these pulleys off to the side, and then I can go ahead and grab the 2 bearings, the smaller bearings, as well as the brass washer here, or the spacer rather. And this spacer is actually going to serve as it's going to serve the same purpose as what the smaller, or I guess wider spacer in the pulleys do. So you want to make sure that it's between the 2 bearings. For these, I can use I believe 2.5mm hex driver, like that. Go ahead and apply my Loctite to one side. And this is 638, so the green Loctite. And place this down, making sure that my alignment is as good as I can get it, and then it should just push into place like that. Okay, now I can do the same thing. So taking the other bearing, putting it onto my 2.5mm shaft, and then putting the bushing into place. The spacer, go in from the other side, make sure my alignment's nice, and there we go. So now we have our idler arm with the bearings set into place, and our bushings also with the spacers in place as well. The next thing we can do is actually we can go ahead and put the tensioner into or attach it to our pulley arm. I like to do it before I mount this into place, because what I've found is that it's kind of difficult to get a good purchase on this mechanism when you're trying to torque down the bolt the bolt that holds down your idler pulley. So if you do it outside of the tensioner assembly, it is a little bit easier. The M5 and M6, you can actually do this. If I recall, I think on M7 you actually can't, because what will happen is you can't get access to be able to put one of the bolts in, but I have already done this before, so I know that it's possible. So I'm going to go ahead and actually grab my Knipex pliers and use these to set or to hold this piece. And what I'm going to do is I'm going to go ahead and grab the correct bolt for this as well. So this is going to be the shorter bolt, or the shorter screw, and this is an M4x14 screw that we're going to use. And this is going to just go through one side like that, and you can see the exposed thread on the other side. For the pulleys for my belt tensioner, I actually use red Loctite for these, just because I don't want any chance of them falling out. And honestly, like if I find that these go bad, I'm just going to replace the assembly rather than trying to, you know, just replace singular bearings and so forth. You'll need a 3mm hex driver for this. So when you go to tighten this down, you'll need to have the correct tools and the way to hold everything in place. And you can kind of see here that as I go to tighten this down, and I didn't put any Loctite on it yet, but you know, you can kind of dry fit it down and just make sure that everything is going to work out well, and figure out how exactly you're going to hold this piece when you go to tighten everything down. So applying red Loctite there, I can go ahead and set this screw into place with the pulley. And holding it, I can go ahead and put a decent amount of torque on that. And once you're done, you want to make sure that your idler pulley is still running smoothly, the no notchiness, and that completes that. So we can then grab our tensioner base as well as the other things that we'll need for this. So if you look at the tensioner base, it has a difference where there's actually a threaded hole here with a kind of a standoff on it, and that's going to actually be the side that the our tensioner arm is going to get bolted onto, and then the other side is going to be where the static pulley is going to go. So if we take our tensioner assembly, we can see that we have our this is kind of like a support arm or pivot arm, and I can stick my screw through, and this is the countersunk screw, the M3 it's actually 16.2 millimeters, which is you know, it's specifically for this application. We can actually then take our mechanism, align everything up, and the screw will have to go in like that. And when we take a look at how everything goes, the little nub that's sticking out of our tensioner arm is going to make contact with this, and that's actually our stop. So the issue here is, if you were to assemble this all and then try to do it or grab it, you'd have to really grab onto this the tensioner arm when you go to torque down your bolt for your idler pulley, because if you don't, then you're going to be putting all that tension into this little nub, and that's not going to be good, and you probably will actually damage things. So really want to try to avoid that. This mechanism as well, I will actually use red Loctite on, just to make sure, or for the pivot screw, to make sure that it doesn't back out on me. And then I can go ahead, using my 2mm hex driver, which is over here, go ahead and grab my screw, and you can align everything up. You want to make sure that you have the tensioner pivot reinforcement aligned as well. We'll tighten this down, and before I actually fully tighten this down, I actually am going to go back and put the 2 screws in that hold the tensioner pivot arm into place. So using my 1.5mm hex driver, and blue Loctite specifically for these, just because with the smaller screw head, I find that if in the event that I actually did have to take this apart sometime in the future, which like I said earlier, I'd probably just throw the assembly out and just get a new one. If I do actually have to take this out, it is a lot easier to do it with a 1.5mm driver. If I'm using blue Loctite, I mean, I probably would end up having to put heat into it, but just this is like the luxury of having choices for what Loctite you want to use where. So tightening that down, I can go ahead and snug these, and then take my 2mm hex driver, go back to my countersunk nut or countersunk bolt, tighten that down, and we can see that this mechanism can now freely move. And you want to make sure that your screw hole actually is more or less aligned with where it would be if it were to be static. Now we won't use this hole. This is probably used in manufacturing or something along those lines, but we do want to have this pivot capable of moving around like that. So once we've done that, we can do the same thing. We take the longer bolt, in this case this is an M4 by 24 millimeter bolt, and stick this through. You want to make sure that you align that spacer on the inside of your pulley. I'm going to go ahead and give this a little bit of a cleanup, just a bit more excess Loctite. Then we take the cone that we have here, and we want to make sure that the narrow side of the cone faces towards our pulley like this. And then I'm going to go ahead and put my red Loctite on the bolt and set it into place. So grabbing my red Loctite, put a decent amount onto there, and then we can go ahead and tighten this assembly down. So now we have both of the idler pulleys for our tail belt into place, and they're both very, very smooth. We can move on to the flight controller mount and the boom clamps. So I'm going to put that off to the side. For our flight controller mount and boom clamps, I'm going to go ahead and move things into view of the screen. So taking a look at what we have here, we have two different lengths of screws available. We have the M2.5 by 5, and these are the shorter ones, as well as the M2.5 by, or sorry, they're actually M3 by 10 screws that are used for holding down the flight controller mount to our boom clamps. You want to make sure that M2.5 and M3 being different sizes, you won't really be able to set one into the wrong place, but just, keeping in mind that there are two different lengths of screw. I'm not going to be using my inertial mass damper. We've actually, kept this around because there are certain flight controllers that have a sensitivity to vibration that can be mitigated using this mass damper, but in my case I find that it's just extra weight, and running what I run, I don't need it. So I'm going to go ahead and not put that together, but I will show you that you basically use your M2.5 by 5 countersunk screws through the plate here, and then you would just kind of bolt this onto the bottom, and the orientation of the mass damper doesn't matter. You just have to make sure that it aligns with your holes. So pretty easy to get that into place. So we have our 4 rubber damper bushings, and these are going to have to be set into our flight controller mount plate here. It's important to note that one side actually has a chamfer, which is what's going to mate with our brass bushing here. So that side is going to face upwards, which is also going to be the side that the chamfer on your plate is going to be on for the mass damper. So you just want to make sure everything is kind of in alignment here. These rubber dampers you can kind of just stuff into place and pull them through. There's many different ways to do it. I kind of like to squeeze them down and turn them into like a little bit of like a taco, and then just push them into place. But just don't use anything sharp because you don't really want to rip them, but just get them into place, and I'll be back when I get these into place. All right, so I've got the 4 rubber dampers, or the rubber bushings, into place, and if we look, like I said, the countersunk side is actually going to be be on the same side as where the countersunk screws are for your mass damper. You can actually take your brass inserts now and set them into place, and you'll see that they mate into place like that quite nicely. And then we want to make sure that we pay close attention to the orientation of these clamps. You can get this wrong, so just make sure that you have the split of your clamp on the right side of the helicopter, or on the right side of your mount, and then that the key up here is okay. You want to make sure really that the splits are on the same side, because you can actually pretty much, it doesn't matter, the flight controller mount itself is not orientation dependent. So as long as you align your splits and they're on the same side like that, you'll be okay. You want to use your M3 by 10 countersunk screws, and these are actually going to you're going to use a 2mm hex driver with these. So go ahead and grab the screw. You can either put the Loctite on it now or wait until you kind of set them through. In my case, it's easier just to put a little bit of Loctite onto them now. So I'm going to go ahead and grab my Loctite 243, which is blue Loctite, and then I'm going to put it onto my bolt or my screw. Then set that into place. Now, like I said, you want to make sure that your splits are on the same side and that they're on the right side. So making sure that your key here is on the left, you can go ahead and put this into the front position. Once I've done that, I can flip this over and see that that split is here. So go ahead and align that split again. Grab another one of the M3x10s. Stick this into place. And then I'll grab my last one here. And just do the same thing. And you can torque these down actually at this point. You don't really need to go super crazy on it, but you do want to make sure that you get enough torque that it won't back out. You know, you do have the Loctite to help out as well, but keep in mind you are going through a brass bushing, so you could crush that. And once you've done that, now your assembly is complete. You can take your palm damper or the palm insert and actually stick this into your rear boom clamp, and this is going to be the one that has no key on it, so just you can put that there for safekeeping, and that will actually conclude your belt tensioner as well as the tail boom mount.